This one just says to, I believe it just says to expand, rewrite as much as possible.
Alrighty.
It really should say expand, and this is using the property log A over B equals log A minus log B. So in this case, it's log base 3 of 2 minus log base 3 of 5.
Oh, all right.
That's it. I mean, that's all there is to do for that one. We doing
Uh,
odds?
yeah. On the number 71. This
71.
log. Wait, let's see if I can do this. Is this log base 2 of 6x minus log base 2 of y?
That is part of it. Um, it's there's more to do here. So this one on the left here is log A times B equals log A plus log B.
Oh,
So
all
we
right.
have to do a little bit with that. Like we have to expand this. It becomes log base 2 of 6 plus log base 2 of x minus log base 2 of y.
Okay.
Okay, now there's maybe potentially more to do on this. Um, um, I don't know. So 6 is really
There's
2 times
uh,
3. Go ahead.
oh, you don't need to expand on it.
Okay, this
We
is
already
what
got the
they're
answer.
looking for. Okay.
Yeah.
In my world, I would make you expand further, but this is not my world. This is South Point Catholic High School, Mrs. Smith's class. So.
Yep.
Okay, 73. I'm guessing.
Yes.
Okay. So this is kind of it's very repetitive because you're doing the same thing over again. Um, you're first simplifying the fraction.
Mm-hmm. So do we uh hmm. Do we cross out the 5 or no?
You have to expand it first. So it's log base 5 of 5 plus log base 5 of the square root of 7 minus log base 5 of 3 minus log base 5 of m. And if you're wondering why there's a second subtraction, we can
I think that makes sense. I can cross out that 5 of 5, turn that into 1.
that becomes 1. The square root of 7 here is really there's a really it's 7 to the 1/2 power, so it becomes log base 5 of 7 minus log base 5 of 3 minus log base 5 of m.
Log base 5 of m. All right. On to number, what is this? 77.
77. Not yet, not 75.
No.
Okay, 77. So kind of the same thing again. Log base k p q squared minus log base k of m.
Mm-hmm.
Log base k. So this over here is a product, so it becomes a sum.
Mm-hmm.
And then always the exponents are always dealt with last because they become coefficients. So this middle term becomes 2 log base k of q minus log base k of m.
All right.
79.
This one. 78.
78. Okay. Okay. The path is the same here. You're gonna use the fact that it's a fraction and separate it. What you might be finding though is that if they're in the numerator, you make them positive, and if they're in the denominator, you put a subtraction symbol in front of them. So you break apart the numerator now. And then the last step is to bring the exponents out in front. So 5 log base z of x plus 3 log base z of y minus log base z of 3.
Makes sense. All right. I just write that down. Log zx plus. All right, on the 79.
79, okay. Snip that one in. All right. Let's just get this right where I want it. It's interesting. Okay, so the first thing I want to do here is I actually want to rewrite this with the square root as a 1/2, and show you that you can immediately bring that to the front. So it's 1/2 log base m r cubed over 5z to the 5th. And then that 1/2 goes with every term. So it's going to be 1/2 log base m r cubed minus 1/2 log base m 5z to the 5th. So then because you're expanding this on the right as a product to a sum, and there's a negative in front, they both become negative. So it's 1/2 log base m r cubed minus 1/2 log base m5 minus 1/2 log base m z to the 5th. Last step here is to move the exponents out in front. It becomes 3/2 log base m of r minus 1/2 log base m of 5 minus 5/2 log base m of z.
That's a lot of steps.
Yeah.
As log. All right, on to 80.
80.
Pretty much the exact same thing. I
Pretty
think I'll try to
much.
do it.
Yeah, I'll write out the final answer and you can compare when you get done there.
This one's cubed. So this one will turn into like a 1/3 on the top, I think,
Yep.
right?
That's right.
All right. Right, m to the 5th over k t squared, and this will be 1/3 on top. So this will turn into like 1/3 log. I did it correctly. I got it.
Excellent, excellent.
Yeah.
That's the goal. That means you're you're ready to
Do these on my own.
take a test on this. Yeah, I mean, which is what's going to happen at some point. I'm assuming.
All right, next on to number says 81.
So these are going backwards. If the previous ones are going forwards, you're compressing these and you're writing them as a single log. So that what the last part I said is really important is that your final answer will have only one logarithm, a single log expression in it.
Hmm.
So it's using the rules in reverse. So because this is a plus, it
It's gotta be
becomes
multiplication, right?
a product, right? Because this is a minus in the middle, it becomes a quotient.
Oh, that works.
And like I said, the answer is a single log. It has to be. That's the nature of these questions here.
All right.
Which one is
Next
next for
is
us?
83.
A3.
So I know I can rearrange this out the bat to log m a squared minus log m to b. Huh.
So the exponent comes up. It's an exponent to an exponent, so it's really b squared to the power of 3. So that becomes b to the 6th.
Oh, I
Still
see
with me,
what you
Jack?
mean.
Okay. And then you
I
can
got you.
rewrite it as a quotient, and again, a single log as your final answer.
All right. Next is number 89.
This one's pretty straightforward. Try this one on your own.
I got log x cubed over y fourth.
Yep, it's x cubed over y to the 4th, exactly. Now, when the base isn't written, the base is 10. You don't have
10.
to write it, but you could write it if you wanted. Both are considered correct.
All right, next is 93.
Okay, so we're going on to the next page. Okay,
Mm-hmm.
so we're doing some simplifications here. Use the change of base rule. Okay, so all right, sorry, I need to snip this in. I forget that part sometimes. The change of base rule. The problem is you can't do this. Like there's nothing to do here. Like there's nothing that this helps with. So there's a property that says if you have, sorry about that, those are not the right words. If you have log base b of a, we'll call it a here, this becomes log a divided by log b. So one log becomes two logs. So this problem here on the left is log 10 over log 5.
Yeah.
And you might think, well, this isn't any better. It's kind of not, but log 10, log base 10 of 10, the numerator is actually 1. So it becomes 1 over log base 10 of 5, or 1 over log 5.
For whatever reason, the book just like puts the the number in the calculator.
Okay, well, then you're depending on the calculator, you can sometimes put this in directly, but you can always for sure put in this step right here and get something out of it.
Okay.
So these are all calculator problems.
Let me see if I still get the same answer. All right. So we got 1 divided by log 5. Ah, perfect. What were we saying?
Nothing more on that. well, the rest of them are just calculator questions in here, so I don't know which one we're going up to, but
Last
95.
one will just be 95.
95. So this one is, it becomes log, I'm going to write it out here, but it becomes log 5 divided by log 15. And you'll get whatever you get for that when you throw it in the calculator.
That's it for this homework sheet. I'll send you pictures of the next one.
Okay, great. I'll be standing by for those to come in. Jack?
Hello. It
Hey,
should be sending.
I got it now. I see 5.4. And
hmm
which question you want to start with?
All right. For this one, I want to start on number one.
For one, okay. The lot here on this one. It okay. So the instructions say to graph the uh, the inverse by hand and label 3 points on the graph. So I think it's best to write the ordered pairs that you see here, like -1, 1/3, 0, 1, and 1, 3. The inverse is the swap of these, so it becomes 1/3, -1, 1, 0, 3, 1. So just swapping or switching positions between the two of them. If you graph those points, and I mean I guess you don't really have the ability to do this, but I was going to say it's better if you can graph them on the same window as that. So 1/3, -1, 1, 0, 3, 1. You actually can't tell, but the inverse is mirrored over the line y equals x, and this one has a graph that looks like this.
Oh,
And it
okay.
actually does not cross the y-axis, which you would have no idea whether that's true or not until I tell you. So, well, I guess they kind of do. They give you this 3 to the x. So we have the domain range increases, decreases, the equation of its vertical asymptote. So there's again kind of a lot there. The domain of the original, write that here, of f, is minus infinity to infinity, and the
hmm
range of the original is 0 to infinity. The domain of f inverse comes from the range, so 0 to infinity. The range of f inverse comes from the domain of f, so that's minus infinity to infinity. So these have to match like that.
Oh, okay.
Now, where is this function increasing? It's increasing on its entire domain from 0 to infinity. It's always going up and to the right.
Oh,
The vertical asymptote, that's the last piece. I don't know how you're supposed to know this. It's at x equals 0. I guess here's how you're supposed to know it. The original function has a horizontal asymptote of y equals 0. So the vertical asymptote over here, you switch x for y, so it becomes x, and it's the same value here, so it's 0.
oh, okay. And we're looking for the vertical asymptote in particular, right?
Yes, that's what it's asking for.
All right.
What is
All
the
right.
next one to look at?
Number three.
Number 3. Okay. So we're going to do something really similar here. I'm going to suggest that we label or we write down the points like I did for this one. Bring this down slightly. And the points are -1, 3, 0, 1, 1, 1/3. And then we're just going to switch the positions. So 3, -1, 1, 0, 1/3, 1. If you graph this, because you don't know anything else to do, you get 3, -1, uh, 1, 0, and that, why did I not? Okay, I'm sorry. I graphed this first from the wrong place. Oh, that's really silly. So 3, -1, 1/3, 1. Okay, so you can't, you wouldn't know this, but it looks like this. Okay,
Oh,
it's an inverted logarithm. So again, I'll make these tables here. For the original function, the domain is minus infinity to infinity, and the range is 0 to infinity.
Okay.
For the inverse, it becomes that. So the inverse is 0 to infinity. The range is minus infinity to infinity. The original function has a horizontal asymptote at y equals 0. You can see that kind of going this way. And that means that the inverse has a vertical asymptote at, you switch the x for the y and get that, and you can see that here vertically. It is decreasing on its entire domain. It's always going down and to the right, the inverse. Actually, that's interesting. Both the function and its inverse are both either increasing or decreasing, which is really sort of odd. But anyway, I actually learned something there. I've been doing this a long time. It's rare when I notice them. We're doing number 5 next.
Next we are on to number 9.
Oh, good, because these are quite lengthy. Okay, number 9. We're going to a new page. Zoom in. Number 9. Okay, find the domain. You may wish to ask your teacher for something else to do. Okay, actually can't read it all. You may wish to support your answer graphically. Okay, the domain. So the domain, you actually just have to look at the inner part here. So so when you have the log of something, whatever's inside here, this something, which I don't have a good name for, you set it greater than 0. So in this case, you're going to set 2x greater than 0, and you're going to solve for x. And it's not much to do here. You divide both sides by 2, so x ends up being greater than 0. That is your domain. The reason is you can only take the log of numbers that are bigger than 0.
Oh. Hmm. It says that it labels it as 0, comma infinity.
Yes.
All right. Number 11, log negative x. That's interesting. It's still the same way that you set it up.
Say that one more time. What are we looking at?
Number 11.
Number 11. Okay, so let me just write it because there's a log. It takes too long sometimes to copy this. So you set the inside part greater than 0. So this one to solve for x, you have to divide both sides by -1. From previous classes, you should know that that switches the inequality.
Oh, yeah.
So that means
I
the
was wondering
domain is
if
from
that's right.
minus infinity to 0. Okay. I hope we do 13 because 13 is a good exception to these problems.
Yes, number 13.
Number 13. Okay. 13. So this problem here, um, it's the same thing that we've been doing. You have to set the inside part greater than 0. So you have to set x squared plus 7 greater than 0. And I've told you to solve for x, okay? And this is kind of an exception. Do you remember what the graph of x squared plus 7 looks like, roughly?
Yeah, goes up. Yeah, goes up
Like
7,
imagine
and it's
that's
a
7, it
parabola.
goes, yeah. So is it ever less than 0, this graph here?
This one? No.
No. So this is always true. X squared plus 7 is always greater than 0 because no matter what you put in for x, when you square it, if it's negative, it becomes positive, it's positive, it stay positive. If you're adding 7 to any of those things, it's always bigger than 0. So this is always true. That means it's always true for all x. So that means it's everything.
Oh, it's everything? Oh,
Yes. Yes.
all right. Number 15.
15. Okay. This one, boy, I don't like the way they've presented it. Sorry here. So a lot of explanation on this one, unfortunately. So y equals the natural log of minus x squared plus 4. So I said this previously. I said set the inside part greater than 0. You still with me, Jack?
Yeah, I'm still here.
Okay. So this graph right here, it starts at 4 and it comes down and it hits at 2 and minus 2 and 2.
Okay, that's understandable.
Okay, so where is it greater than 0 according to this graph? Where is it above the x-axis, in other words?
To the right of -2 and to the left of 2.
Yeah, so in this window from minus 2 to 2.
Okay.
So that's the answer to this. Okay, now there's another way to do it where you have to do some factoring, but this works pretty well. So that, I mean, this, to be clear, this is the answer that they're looking for the domain.
Oh, okay. You got -2 and 2. Yeah. What's the other method?
The other method would be to factor this. So this, if you bring this down, is 4 minus x squared greater than 0. This is difference of squares.
Mm-hmm.
And here it's like 2 squared minus x squared. So that, do you remember how to do this?
Yeah, I think I do. You
So you
factor
factor it
all
like
out.
this,
Okay.
and you realize that these two values are negative 2 and 2. And it's either between them. So like in this previous problem, see how it was between the two numbers, but it could also be outside of them.
Oh. Hmm. Let's set those equal. Oh, okay. All right, let's move on to number 17.
All right, so this is I'm going to just type this one in again because I'm sorry, write it in. Log y equals log base 4 x squared minus 4x minus 21. So this one will factor. You're going to set x squared minus 4x minus 21 greater than 0. So try factoring that.
So, all right, x squared minus 4x minus 21 greater than 0. This would be like x minus 7 times x plus 3. And you set that equals 0.
Yeah, so the
Would
two
it turn
play.
into like, would it turn into like 7, +7 to -3, or -3 to 7?
Well, it's always the smaller to the larger, but here's what's going on with this picture. At -3 and at 7,
Is
you've
when they
got some.
intersect.
Well, that's where it hits the x-axis. So does this parabola open up or down?
This one, oh, it opens up. Okay.
Opens up. So we're looking for where it's above the x-axis.
Oh, it's above the x-axis to the right
Oh,
and the left of -3 and
right.
7.
So if we're doing it on a number line, it's above the x-axis in this region, and then this region over here. From minus infinity to -3,
Oh,
union 7 to infinity.
I see. Okay. So we got -3 and we got 7. And we'll highlight that in. -3, union, 7, infinity. Okay. On to number 19.
Okay. So 19 is somewhat similar. It says y equals log x cubed minus x. So you want to set the inside part greater than 0. Okay. To do this, you have to factor an x out, so you end up getting x squared minus 1. And then x squared minus 1 is really difference of squares. It becomes x minus 1, x plus 1. Okay, so there's actually three
Okay.
places here that this is 0. There's three places. It's at -1, 0, and 1. So the graph of x cubed minus x, if you know what the graph looks like, you'll realize that it comes up, down, and then back up.
Okay. So we got
So that means it's in this region right here that it's good, and everything over here it's good, because we're looking for where it's above the x-axis. So the answer is from -1 to 0, comma 1 to infinity.
how come not union?
Yeah, you can say union. They're both good.
All right, number 21.
Number 21. All right. Okay, so this has got a similar set of issues. Actually, perhaps more. Uh, uh, there's so when you look at what you're really looking at is the graph of this. You're trying to figure out where this is greater than 0. Okay,
Yes.
and there's two issues. There's where the numerator equals 0 and the
Hmm.
denominator equals 0.
Understandable.
So the numerator is equal to 0 at -3 and the denominator at 4.
Yeah.
So if you don't know what the graph looks like, and this is a good example of one where I don't really know what the graph looks like of this thing, you can test points in each region.
Okay.
So you can test like 0 and then 5 and then -5, we'll say. And you're testing them back in the x plus 3 over x minus 4. And here's what's not, like, most students struggle with, is they don't understand that you don't care what the number is. You care whether it's positive or negative, because you just care whether it's above the axis or not.
Okay.
So, like, for example, at 0 it becomes 3 over -4. That's a negative number.
Yes.
At 5 it's a positive over a positive, so it's a positive number.
Okay.
And at -5 you get a negative number up here and a negative number down here. So a negative over negative makes a positive.
Positive. So we know for sure that it's negative infinity to three, a -3, and then 4 to infinity.
Yes, the answer is from negative infinity to -3, union 4 to infinity.
All right. On to number 23.
Let me check this one. I always have the snip covering the previous one. Okay, so 23, we got log absolute value 3x minus 7. So the graph of this, actually, it's kind of interesting. The inside part, 3x minus 7, has to be greater than 0. Now, what you might remember about absolute values is that they v, and this one v's in such a way that this point is at 7/3, or 7 over 3. If any of that's unclear, I mean, I can certainly cover it, but that's what happens. Now, it's always above the x-axis, except at 7/3. So we have to express that it's everything except 7/3, because for every other number, it's always above the x-axis. So it's all the numbers from -infinity to 7/3, union all the numbers bigger than 7/3 to infinity.
That's clear.
This one's just this way because of the fact that it exactly hits the axis. Usually they give you ones that are slightly, that kind of V down here, so you have to figure out what, that window.
Okay. X is 25.
All right, sketch the graph. Okay, 25. So the challenge here with logarithms when you're sketching them is to know how to handle. You have to be able to handle each base, and the base isn't really all that important as much as you know that like the number there changes what you put in for x. So for example, log base 2 of 2 is 1. Log base 2 of 4 is 2. Now, do you know why that is? Why is log base 2 of 4 2?
Um, I don't actually.
Log base 2 of 8 is 3. Log base 2 of 16 is 4. Do you see?
Oh, I see what that is.
Okay, so because 4 is 2 squared, it's the exponent. Because 8 is 2 cubed, it's the exponent. Because of that, it's that. Log base 2 of 1 is equal to 0. So you have to make a table here, but you have to know which x values to try. So in this case, I've given you 1, 2, 4, and 8 are probably good enough. Okay, so log base 2 of 1 is 0, but then you add 3 to it, so this becomes 3. Log base 2 of 2 is 1, plus 3 is 4. Log base 2 of 4 is 2, 2 plus 3 is 5.
4, then 5. And for what would we do for 8?
Same thing. Log base 2 of 8 is 3. 3 plus 3 is
3
6.
plus 3 is 6, yeah.
So I mean, if you follow that, I mean it's not too bad. But your graph here, you got 1 3 2 4 4 5, and then 8 8 6. So you can't see it, but this thing does this like that. And if you look back at the original function, log base 2 of x plus 3, this plus 3 just means it's up 3 units from the original, the parent
Okay.
function. Whereas like 26 is a different kind of shift.
Speaking of 26, let's go on to number 26.
Okay. So this one is more difficult because your goal is to get the numbers inside the parentheses to match up with what you know with logarithms that you know how to calculate. So like you know how to calculate the log base 2 of 1. You know that that's 0.
Yeah.
Okay. So but this is x plus 3. So here's what you're asking. You're really asking, how does x plus 3 equal 1? Well, that's when x equals minus 2. Next, just kind of follow me here. So log base 2 of 2 is 1, but this isn't, we want x plus 3 to equal 2. So to do that, x has to equal negative 1. Log base 2 of 4 is 2. Well, how do we get x plus 3 to equal 4? Well, x has to be 1. And then we did log base 2 of 8, that's 3. Well, how do we get x plus 3 to equal 8? Well, x has to be 5. So this will all make sense in a moment. We're going to make a table here. Your x value, though, are these ones over in this column, so minus 2. So follow me now. Minus 2 plus 3 is
2
1.
minus 3? Yeah, 1.
What is log base 2 of 1? Well, I've hidden it, but it's over here. Log base 2 of 1 is 0.
0.
Now I'm going to grab negative 1. What is negative 1 plus 3? It's 2. What is log base 2 of 2?
Log base 2 of 2 is 1.
1.
We got log base 2 of 4 is 2. Then 2 of 8 is 3.
Right, but we're not putting 1 in for x because of this over here. Because if you just arbitrarily picked a number, and I'll do that next year. So log base 2 of 1 plus 3 is 4. This becomes 2. Again, if you weren't paying attention, you're just like, well, I'll just put whatever I want in there. Let's put 2 in. Well, this means log base 2 of 2 plus 3, which is log base 2 of 5. Do you know log base 2 of 5? No. And you can't use a calculator. So you have to get it to a value that you know. That's why that one's no good. But 5 is okay because it's log base 2 of 5 plus 3, which is log base 2 of 8, which you know is 3.
3. Ah, okay.
And this gives you enough to be able to graph this thing in such a way that you can get something reasonable out of it. So minus 2 0, minus 1 1, 1 2, 5 3. So it ends up looking something like this for you. All right, Jack. So we are out of time for today. Um, let me get these notes off to you in the screen recording,
Alrighty.
and I'll talk to you next time.
Thank you. Bye
Thank you.
bye.
Bye now.